Thanks for dropping in. Last week, I introduced this vertical parts drawer made from an empty filament spool. Makers have been turning empty spools into storage boxes for years, but this design uses a new vertical layout, ideal for supporting more bins and smaller items. But as I mentioned last week, the project is useless if you aren't using a spool that's the same size as the one I based my design on. There needs to be a way to customize the design for a broad range of sizes, and that's where OpenSCAD, a script-based 3D design program, comes in. Let's run through the process of creating a customized bin using this printed solid filament spool. First, we need to get 3 measurements: the outer diameter, the inner diameter, and the inner width. The outer diameter is self-explanatory. Just make sure you're measuring the full diameter of the spool. If it has a molded design on it, like this one does, that pattern can be an excellent guide to make sure that you're measuring straight across the diameter of the circle. Try to be as accurate as possible. The model already has some wiggle room programmed in, so it's best not to add any more padding into the calculations if it can be helped. However, if you are unsure about this measurement, it is best to round down. The inner diameter is trickier. It is not the diameter of this hole in the spool. The inner diameter refers to the diameter of this side of the internal wall. Hopefully, the molding on the spool will provide a clear indication of where this wall ends. If all else fails, use a piece of string to get the circle's circumference and divide by pi to get the diameter. If in doubt, this measurement should be rounded up. Otherwise, the bins won't have enough room to wrap around the inner core of the spool. The inner width refers to the space between the sides of the spool. Make sure not to distort the sides of the spool while taking this measurement. This is another measurement that's best to lowball if needed. Now that we have all our measurements, we just need to download the script for this project from Thingiverse and run it in OpenSCAD. If you don't already have OpenSCAD, it's a free download for Windows, Mac, Linux, and more. You can also use the online customizer tool by Thingiverse, but I haven't had much luck getting it to run smoothly or even to export the results. Within OpenSCAD, you'll see a rough preview of the model, and to the right, customization options. Let's enter those measurements and see how that looks. Depending on your computer, changing each property could take a while. The render also may not look perfect or rotate smoothly, but all that's fine right now. We just want to get the data into those fields. There are several other customizations also available. Resolution controls how smooth curved surfaces on the model will look. 200 is probably more than enough. Lock tolerance controls how tight the sliding lock pieces are within their tracks. This only affects the size of the lock parts themselves. If you've printed a bunch of bins and the fit is too loose or too tight, you'll only need to reprint the tiny locks, not the bins themselves. The lid checkbox is new. If you plan on removing multiple bins from the drawer at a time, you may want to use this style so that rotating the drawer doesn't cause a mess. The Split Guides checkbox will make a thin cut in the guide parts so you can wrap it around the spool. This is not necessary for some spools that can be disassembled, like Printables spools. There are 3 handle options available: no handle, flat, or curved. Just pick whatever looks best for the sizes you've entered. Note that some handle styles just don't work with very small bins. Once you have your settings in, click the Render button to generate a higher quality render. If everything in the render looks good, click the STL button to save and export of your customization. When you open this STL file in your slicing software, it may come in as one single object. If it does, split that object into separate parts and orient them all for printing. While testing this, my slicing software would occasionally report that it found and repaired errors within the object's mesh. This only happened for certain sizes and never prevented the slicer from actually producing a good print. I strongly recommend that you print one of the guide rail parts first. It's a quick print, and it will become fairly obvious if any of your measurements are off when you try to attach it to the spool. Speaking of attaching the guides to the spool, in last week's video I recommended using glue. After printing a few of these, I think I can safely say that glue is recommended, but not necessary. Once you have a few bins in, the parts hold each other in position quite well. Next, print one bin, and one set of locks. Do not do what I did and print a whole set of locks, only to realize that the tolerance setting was wrong and all the locks were worthless. If the locks in the bin fit nicely, print the rest. I still have a lot of printing to do before I have enough drawers for all of my hardware, but I'm getting a lot of use out of what I've printed so far. I'm actually quite surprised with how well these spools stand on a shelf vertically without rolling off. I still plan to design some sort of stand in a future video though. The new OpenSCAD version of this project is available on Thingiverse. With that post are all the measurements I've made so far for the spools I own. If you create your own drawer, please consider sharing your own settings with the community in the comments section for that project. So until next week, happy printing and thanks for stopping by.